Good morning, this is Mr. Eicher, trying something very novel today, recording the lesson on my iPad, and you're listening to me right now. This is very awkward to be talking at an iPad, but let's begin the lesson. In this chapter we're talking about sequences, which are basically patterns. You can see in your class notes that the substitute passed out. We're on chapter 11, Arithmetic Sequences. A sequence is a list of numbers in a particular order. Each number is called a term. A sub 1 is the first term, A sub 2 is the next term, and A sub n is the nth term, which is usually the last term. So let's consider this question. Find the next four terms of each arithmetic sequence. Now, 31, 24, and 17, you'll notice that between 31 and 34, there's a difference of subtracting 7. And 24 to 17, there's a difference of subtracting 7. So we would say the common difference is negative 7. And then the next four terms, you just subtract 7. So 17 minus 7 is 10. Minus 7 is 3. Minus 7 is negative 4. And minus 7 is negative 11. Sorry that the writing isn't as elegant as my normal writing on the board. The next sequence, negative 8, negative 5, negative 2, the common difference is what? Oh, there's no one here to answer. So I guess I have to answer it. The common difference, let's see, from negative 8 to negative 5, you're adding 3. Negative 5 to negative 2, you're adding 3. So to find the next four terms, you add 3. So that would be 1, 4, 7, and 10. The next one with fractions, the common difference, all the denominators are the same, which is really helpful. And we have 18, 16, 14, so that's subtracting 2. So the numerators are going down by 2, the denominators are staying the same. So that would be our common difference would be negative 2 over 5. So the next four terms, you subtract 2, that would be 12 fifths. Subtract 2 would be 10 fifths, which we should write as 2. And then we have 8 fifths. 8 fifths. Then we have 6 fifths. So we'd have 12 fifths, 2, 8 fifths, and 6 fifths with a highlighter. Nothing like a highlighter. And the next one we have decimals. See if you could figure out the common difference and write the answer on your paper. So the common difference, we are adding 2.5. So the first one you should have had was 8.8, and then you have 4 after that, but I trust that you got those answers. So let's move on. So next in the notes, we have a definition of an arithmetic sequence. An arithmetic sequence is a sequence in which you add some common difference d to a term to find the next term. And that's basically what we were just doing. So the directions say find the first 5 terms of each arithmetic sequence described. So a sub 1 is the first term. It's helpful that they give us that. Common difference is 5. Notice it's a positive 5, so we add 5 to find the next term. And then we add 5 again to find the next term. And we add 5. And how many are we going for? Find the first 5 terms. So we have 1, 2, 3, 4, and 61. There we go. So those are the first 5 terms of the arithmetic sequence. The next sequence, we start with 12. That's our first term. And we have a difference of negative 3, notice this time. And that means we have a minus 3, so that would be a 9, a 6, a 3, and a 0. And next we have a fraction. I'll give you a second to see if you could figure out that one. So the answer you should have is 5/8, and then you'd have 2/8. Subtract. Subtracting. I should be adding. That's an easy fix. 8/8. 11/8. What are we at? 14/8. 14/8. And 17/8. Now for this one right here and this one right here, you should simplify those. So you should have 5/8 and then a 1, 11/8 and then a 7/4. Sorry, that's kind of hard to read. On the next one, we're given a function basically, a sub n equals 1 minus 5n. What is a sub 10? It looks confusing, but basically you have your a values defined to be 10, and that's going to be plugged in to the function 1 minus 5 times 10. So that would be 1 minus 50. 1 minus 50. So the 10th term in the sequence is negative 49. On the next part of the notes, we're going to try to find a pattern that would give us a formula for any arithmetic sequence. Okay, so let's consider this pattern. A sub 1 is the first term, a sub 1. To find the second term, a sub 2, we would take the first term plus d, the common difference. To find a sub 3, we could think of it as a sub 2 plus d. But instead, let's think of it as a sub 1 plus d plus d. And again, sorry, this handwriting is really bad, but listen carefully. To find a sub 4, we could do a sub 1 plus d plus d plus d. So that would be a sub 4. A sub 5 would be a sub 1 plus how many d's? Well, we'd have 1, 2, 3, 4. So this is what we have so far. A sub 5 equals the first term plus 4 common differences, 4 d's. So a sub 5 equals a sub 1 plus 4d. So that means a sub 6 equals a sub 1 plus 5d's. A sub 7 equals a sub 1 plus 6d's. A sub 8 is a sub 1 plus 7d's. A sub 9 is a sub 1 plus 8d's. So now to the general formula. A sub n. Ooh, can't see that very well. Need to fix that. So a sub n, that would be a sub n is the first term, a sub 1, plus how many d's is the question. How many d's? Okay, turning the next page, here's the formula that we just came up with. Find my highlighter, since we love highlighting things. The nth term of an arithmetic sequence, the nth term, a sub n, of an arithmetic sequence is the first term and common difference d. Here's the formula. Bam. Nothing like a highlighter. A sub n equals a sub 1 plus n minus 1 times d, where n is any positive integer. And I do want you to memorize this. There are several formulas in this chapter I'd like you to memorize. The next question is basically plugging some numbers in. Find the indicated term. We have a sub 1's negative 4, so it's starting at negative 4. The common difference is negative 9, and there are 20 terms. So this n equals 20 is really important because that tells us what term we would like. So we want to find a sub 20, and with our formula it would be the first term plus something times negative 4, and if you remember from the previous page, it was your n minus 1, so that would be a 19. So when we calculate that, we would have negative 4 minus 19 times 4, sorry, that's a plus, sounds like that would be 76. So the 20th term in that sequence, the 20th term is 72. So if you actually, just started subtracting 9 a bunch of times, you'd have negative 13,
Is there no?
Uh-oh, we better start again. I made a mistake on the last one. Did you notice? That's the problem with recording my lesson without students around. Who's there to correct all my mistakes? So let's begin. Here's the general formula. A sub n equals a sub 1 plus n minus 1 times d. The d was my problem last time. So we want the 20th term based on n equals 20. So a sub 20, the 20th term in this sequence, equals the first term, negative 4, plus 20 terms minus 1. That's how many times we're adding d. And see if I can get the d right this time. Negative 9. I think I wrote negative 4 last time. That would be a problem. So solving, we would have negative 4 plus 19. Ooh, uh-oh. A little hard to write on the iPad. 19 times negative 9. And simplifying that, we get negative 175. Be really careful with order of operations. Sometimes students want to take these two, oops, can't see them now, negative 4 plus 19, and then multiply by negative 9. These two. But order of operations, you need to multiply, oh, look at this option. You need to multiply these two terms first, and then add negative 4. Okay, moving on to the next one. You need to find the 12th term. So we have a sub 12 equals the first term, which is 8, plus how many terms do we have? Well, we have 12 minus 1. And then we need the common difference. Now you have to think for a few seconds, I guess, to see what is the common difference between 8 and 3, and then 3 and negative 2. Well, that would be a difference of 5, and it's getting lower, so it's negative 5. So we would get 8 plus 11 times negative 5, which would be 8 minus 55. So the 12th term in this sequence is negative 47. Okay, the next two types of problems, usually students struggle with these. Write an equation for the nth term of each arithmetic sequence. You're going to use your general form, a sub n. Oh, I better zoom in. Writing's way too big if I do that. See how big that is? Let's get rid of that. So you have a sub n equals a sub 1 plus n minus 1 d's. And you want a general form for a sub n to generate any term in the sequence. First term is 7. We don't know the number of terms, so we leave that as a variable n. And the difference, well, from 7 to 16 is adding 9, 16 to 25 is adding 9, 25 to 34 is adding 9. And it should always be the same difference if it's an arithmetic sequence, so times 9. And then we just simplify from there, which would be 7 plus 9n minus 9. So our general formula would be a sub n equals 9n minus 2. And that's our answer, which, but I'll bust out the box again. Yeah. And the next question is this one. See if you can figure out this. Pause this video and see if you can write the formula. So you would have a sub n equals the first term plus n minus 1 times d. Be careful about this d value. Is it positive 2 or negative 2? Let's see. D value would be negative 3 to negative 5 is a negative 2. So you would have negative 3, that's an equals. Just imagine that it's an equals. Negative 3 minus 2n plus 2. So our general formula would be a sub n equals negative 2n minus 1. And that's our answer. Really like that box. The box might replace the highlighter. Is it possible? Moving right along. Next, a word problem, and then we finish with the lesson. So, table below shows typical costs for a construction company to rent a crane for 1, 2, 3, or 4 months. Assuming the arithmetic sequence continues, how much would it cost to rent the crane for 12 months? So we can use an arithmetic sequence. Notice that there's a common difference. The common difference would be, common difference here would be $15,000, and here another $15,000, and then $15,000. So we have our first term, $75,000. We have a common difference, and we want to know 12 months. So a sub 12, the cost after 12 months, is the first term, which was 75,000, plus 12 minus 1, times $15,000 difference. So you'd have 75,000 plus 11 times 15,000. And the answer you would get is that after 12 months, a sub 12 is 24000. So the 12th, did I spell that right? Months. The 12th month costs $240,000. And the last type of problem says find the missing terms. Missing terms in a sequence are called arithmetic means. The idea with arithmetic means, you're given the first and the last term. Notice right here, the first term, last term. You also know how many terms you have in your sequence. 1, 2, 3, 4, 5 terms. So we have a sub 1 is 55. A sub n, a sub 1 is 55. A sub n is 115. N is 5 terms. And d, well, that's what we're solving for. If we know d, the common difference, then we could just add or subtract it to get the missing terms. So the work would look like this. You'd have 115 115 is your last term, equals 55 plus 5 terms minus 1 times d. So you have 115 equals 55 plus 40, not 40, but 4D, D as in dog. Subtract 55 from both sides, and that sounds like 60 equals 4D. So D divided by 4, D is 15. Now you're not done, you actually have to go back and insert numbers. 55 plus D would be 70, plus D again, 15 over here, is 85. And 85 plus 15 is 100, and it should work in the end, thankfully, and it does. 100 plus 15 is 115. I'll let you try the last example. My only caution is notice the number of terms is different. So you can try that, and once you get your answer, check your answer with a neighbor, and then you can begin your homework. Thank you for listening to this video brought to you by Mr. Eicher.